Hello guys, how are you? I hope you all are fine. Take some cup of tea and music and let's start our today's mathematics. So, about chapter number 2, we have already discussed about derivatives and some of its examples. So, now today we will discuss some important definitions of this chapter number 2 differentiation. So, let's start. Firstly, I will discuss about the Maclaurin series. It is a very important definition and Maclaurin series. And for solving question, we have to understand what is Maclaurin series. As it's shown from its definition, it is basically a series. That's a function f of x. A function f of x is equal to f of 0 plus x f prime of 0 plus x2 by 2 prime f double prime of 0, similarly and so on. It's called, what is it called? Maclaurin series. Maclaurin series. In the next lecture we will discuss about its question, then you will easily understand. And the second and very important series is Taylor series. Taylor series. You have to keep in mind the difference between Taylor and Maclaurin series, so you can easily solve its question. In Taylor series, there are two functions, variables x and h. These are equal to f of x plus h f prime of x plus h2 by 2 factorial f double prime of x plus h3 by 3 factorial f triple prime of x and so on is called, what is it called? Taylor series. Taylor series. Prime in a prime of functions means the derivative. First prime means first derivative, second prime means second derivative, and third prime is third derivative. Now we will discuss about the functions, some important functions for short questions. Increasing and decreasing functions. What are the increasing and decreasing functions? Solving questions about increasing and decreasing function, you must know what is increasing and what is decreasing function. So let's write its definition. A function f is increasing if a function f is increasing if on interval, like having some interval a b, on interval a b, if f of x2 less than equal to f of x1, f of x2 greater than f of x1, or f of x1 less than f of x2, where x2 greater than x1 for all x1 and x2 belongs to our interval. Which one is our interval? AB. Function f is increasing if for interval AB f of x2 greater than f of x1 and x2, this x2 greater than x1, and from where x2 and x1 comes, it comes from our given interval. Similarly for decreasing function, decreasing functions, function f is decreasing When will a function is decreasing? If for any interval, what will be the interval? A B. If this f of x2 less than f of x1 and x2 less than x1, also this x1 and x2, this means for all x1 belongs to our interval A. For increasing function f of x2 greater than x1 and for decreasing function f of x2 less than f of x1. The other type of function is stationary point. Stationary point. It is not as important as increasing and decreasing function, but sometimes examiner asked in MCQ, so you have to know about the stationary point. What is the stationary point? Any point where the function is nor increasing nor decreasing. Simple. Function is not increasing and nor decreasing. We know about the conditions of increasing functions and we also know about the decreasing functions. If these two conditions are not satisfied and some other conditions, some other answers are given, so function is stationary.